So you're watching the Unit 0 review. We're going to cover everything. I'm going to go over these things slow. I'll probably make a couple parts for this video. The first thing I want to cover is parentheses. We want to talk about what these things mean and how we can change them. So you can add as many parentheses as you want to something, right? So let's just be clear about this, right? X is the same thing as X in parentheses. There's no difference there, okay? Another thing that we should realize, right? So I'll give you another example. So that means that 3 is the same thing as 3 in parentheses, right? There's nothing different there about that. Okay, the parentheses is just like a way of making sure that we're being precise about what we're talking about. And so another example would be something like maybe -2, okay? If I put -2 in parentheses, that's the same thing as just -2. But in a second, we're finally going to get to the first situation where we have like a problem, right? What's the difference if the negative is outside of the parentheses? All right, these two things look different, but in this case, they have the same meaning. Okay, so both of those things just mean -2. Well, this might feel like it can't be that complicated, but in a second, we're going to realize that things are going to get a little bit more messy, okay? Because now when we add another symbol, people start having problems. So far, I just shown you one symbol, okay? So we'll do one last one, okay? What happens if I put a -3? What does that mean? Okay? So -3 just means +3, okay? So we got to realize that when we have a negative outside of a parentheses, this is like an invisible -1. Okay? And whenever you see a number outside of a parentheses like that, it means to multiply. Okay? So we could write that with some kind of numbers or something like that. Like if I was to put negative x, right? What does this mean? Okay, I would want you to realize that this just means +x, okay? 2 negatives make a positive in this case, okay? So again, it's like multiplying. It's like doing a negative times a negative, and it makes a positive. So now when we add another symbol, like I was trying to tell you guys, another variable or another number, this is where we get all kinds of questions. So let's look at a couple of situations. We might have 1 - 2. We might have 1 - 2 in parentheses. We might have parentheses 1 - 2. I'm trying to think of any other way that this could look. Like, what would you guys think if you saw something like this? 1 minus and then it just closed and it was parentheses? You'd have to see that this is meaningless, right? This doesn't mean anything because we just can't have minus and then a blank. So this is something you'll probably never see, okay? So that can't be. So what do all of these things up here mean? Okay? 1 - 2 means -1. Okay, again, if I look at the number line and I start at 1, okay? I start at 1, and then I say, okay, it says -2. So minus means I'm going to go to the left. So I'd have to go to the left 2 steps, right? Again, -2, right? It means I'm going to the left 2 times. And that puts me at -1. Okay, so we're just counting, right? Well, we got to realize this means the same thing. Okay, so 1 and then a parentheses and a -2. It looks like the same thing, okay? But in this case, what we actually have is that this is a multiplication. So whenever you see a number and right outside of parentheses like that, that means to multiply. So this one ends up having a different meaning. You see, this one means -2. Okay? So it might look like they mean the same thing, but they don't. And this is where I realized that we're already having some misunderstandings. It's all about the parentheses here. Okay, in this case, we have 1 - 2 in parentheses, and this just makes and negative 1, and we might leave the answer in the parentheses like that, okay? So we're going to talk about these different situations and make sure we understand when we have what situation, what we're supposed to do. Okay, one of the problems I'm having lately is what happens if I do something like this, like 3 minus, and then I have parentheses, negative 2. Okay? In this case, again, we want to remember that the 3, I can't change it, but because I have minus a negative, right? Minus a negative means to add. So this means plus 2, and 3 plus 2 is just 5. So let's go look at some examples on our paper. Again, this is like me really trying to slow down for integers. But let's look at some examples that we have here so that we can get some more specific ones. So looking at number 1, on this problem, it looks like we have 1 plus negative 2. So as I was saying earlier, we want to get rid of the parentheses so that we can evaluate the expression that we need to. So we just drop the parentheses in this case because the meaning is correct. 1 minus 2 means negative 1. Okay, and again, look at your number line and count if you're not sure. We got 0, we got 1, and we have negative 1. In the classroom, the number line is on the wall. But if you're at home doing your homework, you might want to print out a number line and just write one down and just count it out. It won't take you that long to make one. Okay, and as we see again, if I start at 1, and if I go minus 2 and take 2 steps to the left, we see I'm at negative 1. So that's how we got this value. Okay, if we look at 2, we want to understand what's happening here with these parentheses. Again, that's the thing that's causing us the most trouble. Well, because this is just a number in a parentheses, I can get rid of it, and that just becomes minus 2. But this next part that says minus a negative, right? Okay, I could put both, I could drop that second parenthesis and put minus negative 7. Okay, and what is the meaning of this? What does it mean to subtract a negative? Subtracting a negative means to add. Okay? So, minus 2 plus 7, again, if we start here on the number line at negative 2, okay, it says plus 7. So this is going to move me to the right 7 steps. So if I count 1, 2, 3, 4, 5, 6, 7, you should be able to see where you're at, okay? And that would put us at 3, 4, and 5, right? Okay, so we would be at positive 5 for this value for number 2. For number 3, again, we have parentheses here and we can get rid of them, and so we want to get rid of them so that we can just do the calculation we have to make. So this has the same meaning as negative 5 minus 5. And again, if I start at negative 5 right here somewhere, right? And if I take another 5 steps to the left, where am I going to end up at? I would end up at negative 10. Okay, so this is one topic that if you need more practice, you just need more practice, and it comes with the territory that you're going to get faster once you get more exposed to it. So we'll do 2 more problems, and then I'll save number 6 for your own homework, for your own purposes, all right? We have here 4 minus 6, okay? So plus a negative means subtract, right? So now 4 minus 6, okay, because I'm taking away a number that's bigger, right? The negative number is bigger than the positive number. So that means my answer is going to be negative. So a lot of times students will ask me, hey, what's a negative plus a positive? And the answer is, I don't know, okay? It depends. Is this number 400? Okay? Because 400 minus 6 is a lot bigger than 4 minus 6, right? So it depends which number is bigger, okay? If the negative number is bigger, your answer will end up being negative. Okay, if it's the negative number smaller and you're adding it with another number, then your answer will be positive. So we'll look at number 5. For this one, again, we're mainly dealing with the double negatives. That's the part we want to deal with. So the negative 2, we'll just write it here. We got negative 2 plus 7, and then minus 3. Okay, so we just want to combine these numbers. Negative 2 plus 7 makes positive 5. Again, if I start at negative 2 and take 7 steps, you're going to see that I'll end up right here at 5. Okay, but then I got to do 5 minus 3, which gives me 2. Okay, so I'll probably make a much longer integer video to go through this in much more detail. But for now, you guys should be able to practice this. And if you're having trouble, please let me know so that we can focus a little harder on that. So now we will move a little farther down this sheet because I want to do the rest of this assignment. So we'll work on these fractions right now. And it looks like what's missing is this idea of how to actually multiply fractions from this sheet. But luckily we did that on an assignment a while back. So let's start with number 7. The first thing I want you guys to understand is the word denominator and numerator. Okay, so the number on the top of a fraction is called the numerator, and the number at the bottom of a fraction is what we call the denominator. Now this idea actually should make sense. This word denominator, okay, comes from the denominations of something, right? So it means the way that we're counting these things, okay? So what are we counting them as, right? One word that you guys should understand, again, like I said, denominations, okay? We have several denominations of money, of bills in this country that we use. One of the denominations would be dollar bills, okay? That's one denomination that we have. We have dollar bills, okay? Another denomination would be $5 bills, right? We know these are different, right? If I have two $5 bills, right? Two $5 bills is worth $10, right? So we know to count them differently than $1 bills, right? I know that two $1 bills is worth $2, right? So that's what denominations really means, right? It means, what is this thing that I'm counting? What does it really stand for? Okay, the number on top of the fraction tells us how many do I have of this thing I'm counting. And again, the number on bottom, the denominator, tells us what kind of thing are we counting. Are we counting halves? Are we counting thirds? Are we counting fourths? And so on and so on. Okay, so in this one that we're talking about, we have two fractions that both have the same denominator. They're both a 7. So in this case, it's just a counting problem. We keep the 7 on bottom because we know these are both counting 7s, and I know I have 12 of them and 4 of them. So we combine it into one fraction. And then in the next step, we'll add those numbers so that we can see what we have. Okay, so 16 over 7 would be the correct way to do this problem. Then we'll take a look at number 10 because this one's also easy. Notice that it's different than number 8 and number 9, where the denominators are not the same. Okay, in number 10, the denominator is the same. So that means I can combine them into one fraction. All I have to do is look at this operation. Notice that this time it's a subtraction, whereas this time it was an addition, right? So there was a difference there. So that means up here, I'm not going to write 7 plus 4, but I'm going to write 7 minus 4. And then we can do that calculation in its own step. 7 minus 4 is 3. And so we have 3 over 5, and that's complete. Now, there's more than one way to do these problems when they have different denominators. But I want to just try to show you one technique, and then eventually when you guys get smart, you'll be able to skip some extra steps. But for now, what I usually teach people is skip and leave some even empty space in between the equal sign and your fraction. And then over here, we copy everything else. All right, now what we're going to do is put a couple blank fractions right next to them in parentheses. And this is going to be the part that I've been focusing on lately, has been how do I get the number that I'm going to put in the green spots, and how do I find the number that I'm going to put in the blue spaces up here on top and bottom? Okay, so the place that I get the blue number, okay, is I'm going to look in the other fraction and I look at the denominator. So this number is where I'm going to look. So for this one, I'm going to go put 2 on top and bottom. The blue number is 2. Okay, what do you think the green number is going to be? I'm going to go highlight the green number right now. The green number is going to be the denominator of the other fraction, right? So when I find the green one, I go look at the other fraction and I look at the denominator, the number on bottom, which is 4. So that means here I got a 4 and a 4. Okay, when we're multiplying fractions out, then what we do is we do the top times the top and the bottom times the bottom. And this is because it's the definition of multiplication. So if we do 2 times 1, we have 2 on top. And on bottom, we have 2 times 4. And that's 8 on bottom. It's fine. You're okay. Thank you. And so if we do the next one, we get 3 times 4 on top. And that will give us 12. And then on bottom over here, we get 2 times 4 is 8. Now notice that both of these fractions have the same denominator now. That was not an accident, right? That was on purpose. We wanted it to be that way. Because we picked 4 and 2 and 2 and 4, it had to be, right? So in this step, because they have the same denominator, we can combine the numerators. We'll add them. Now we have 8 on bottom, and on top, we have 12 plus 2, which is 14. And we end up with 14 over 8. Okay? The final step would be to reduce this fraction and break it down all the way and realize that we have 2 times 7 over 2 times 4. And so we can cancel the 2's and end up with 7 over 4. So the final answer for this problem again would be 7 over 4. That's what you would want to get. So let's reflect on what happened on all the steps, right? The first thing we did was recognize that we did not have the same denominator, right? We saw these two numbers were different, okay? So then we skipped some equal space in between the equal sign, right? We made some empty space, and then we added those two little fractions to help us change the form. And then once we changed the denominator, we combined them nice and easy. So in number 9 over here, we'll do the same thing. We'll leave some empty space. And then we'll write 7 over 4, or write 7 over 6. And then now again, like last time, we're going to talk about what numbers would go on top and bottom here and here. What do they have to be? Okay, well, I'll grab the highlighter tool, and then we'll take a look. Okay, what goes for the green number on top and bottom here? And what do we need for the blue number on top and bottom over here? Well, I hope you guys can see that the green number is going to be 4, right? Again, we're going to look at the other fraction, okay? And its denominator. That's going to be the 4, okay? To get the blue one, I got to look at the other fraction and look at its denominator. And that's what happens, okay? So now let's go drop the numbers where they go. Okay, the 6 will go here and there in the blue places, and the 4 will go there and there in the green places. So now we just have to calculate. We do the top times the top. Okay, 6 times 7 is 42. If that times table is hard for you to remember, you should probably go over your 6's and your 7's because these numbers aren't that big, and so they'll be around a lot. So I would highly recommend knowing those. So if you got to remember your 6's and 7's, just put in the work for a week or two. You'll remember them eventually. All right, 6 times 4 is 24. We put minus, okay? And then on top, we got 7 times 4. That's 28. And then on bottom, we got 6 times 4. And that's 24. Well, because they're both equal to 24, on bottom, we don't have to change the numerator, and that means that we can combine them on top. So now we can finally write them as one fraction with 42 minus 28 on top, and the last step, or second to last step, sorry, would be to write, we have 24 on bottom, okay, but 42 minus 28 is 14. Okay, so the last step, like we were talking about, would be to reduce any other numbers that are in there. So we know that 14 is 7 times 2, okay? And that 24 is 12 times 2. So I can cancel the 2's, and we would be left with 7 over 12. And again, this is all for number 9. So there we go. We got some work for number 9. Okay, so pause that if you need to go over anything, review, and make sure that you're clear about it. But we'll continue working through this worksheet. Okay, so we have now products. Okay, so we're going to talk about the basics of a product. Okay, the product. Okay, the product of two numbers is the number that you get when you multiply it. Okay, so we could even write the sentence out. The product of -7 and 5 is -35. Okay, so we want to understand a couple things, like what do these parentheses mean, like we were talking earlier, right? I was just dealing with one parentheses and one symbol. Okay, but what we have to know now is that when we put two parentheses next to each other, it means multiply. Okay, it means the same thing if we put two letters next to each other, right? If I write AB, that means A times B. Whether or not I put that little dot in between it, it still means A times B. Okay, the same thing if I write A, parentheses, B. Okay, if they're both in parentheses, that means multiply, and it would be the same thing if I had only one of them in parentheses. All right, that means multiply too. So, again, the product is just the value that you get when you multiply two numbers together. Well, we have to know that a negative times a negative makes, a negative times a positive makes a negative. Okay? So you'll notice on 12, 14, and 13, in every single case, we have a negative times a positive. So that means every single one of these values should work out to be a negative value. Okay? Because a negative times a positive is a negative. Okay? We all know that a positive times a positive is a positive, right? That's why you learned those values first when you were in school. Okay? But a negative times a negative also makes a positive. Okay? So the only time that you're going to get a negative number is if you're multiplying two things that have different signs, right? If you have a positive times a negative, then you will get a negative number every time. Okay? The same rules apply for division. So if we are dividing a negative divided by a negative, then we will get a positive number likewise. So let's go take a look at these examples to see what I mean. Okay? So in this case, we have a positive divided by a positive. That's positive 8, right? Because 8 times 3 makes 24, right? Okay, but now a positive divided by a negative. Okay, a positive divided by a negative makes a negative. And because we have the same number, it's a -1. Okay, so think about it. We know that 7 divided by 7 is 1. Okay, so the only difference is that we have a -1 because one of these is a -7. Okay, so the point that I'm trying to make is what would happen if I had -7 divided by -7, okay, and that is +1, okay, because a negative divided by a negative makes a positive. So the rules work the same way as multiplication. Okay, so here what do we got? 16 divided by -4. Okay, well, that's a positive divided by a negative, so I know my answer has to be negative, and that's going to be -4. Okay, and again, think about it. If I multiply -4 times -4, I get +16, right? A negative times a negative is a positive. All right, this last one, 56 divided by -7, we get -8 this time. So a negative times a negative makes a positive, remember? So this is the way that division works, okay? This is what 56 divided by -7 means. It means what number do I multiply times 7 so that I can get 56, okay? And the answer is -8 is what I need. So don't forget, a negative and a positive, if we mix them up in division, okay, if they have different signs, we're going to have a negative value. So that brings us a little farther down to the other side where we have a couple expressions for you to evaluate just to make sure that we didn't forget everything about the order of operations. Okay, on this problem, we would have to remember what 4 squared means, and 4 squared means 4 times 4, right? And that is 16. Okay, so 16 minus 1 is just 15. Now on this problem, we have 5 minus something, but we got to understand that 4 divided by 4 is just a big 1. Okay, so this is really just 5 minus 1, and 5 minus 1 happens to be 4. All right, it's a coincidence that it happens to be 4. So now for this one, we should remember that now we actually have to look at PEMDAS. Right, this is the first time that we really maybe would have made a mistake. Okay, we have to do the parentheses first, so anything inside the parentheses is what we should do first. Now in this case, we don't really have anything going on inside of them. Okay, so now we can move on. There's no exponents, right? That's what the E stands for, the exponents. Okay, so now we move on to the multiplication. Okay, so multiplication, we could do that right now. That's 3 times 2, that's 6. Okay, so this is telling me to do 5 plus 6. And 5 plus 6 is 11. Okay, on this problem, let's make sure that we understand the way we're going to do this from left to right to make things nice and neat so that we're not falling apart, okay? There's a couple ways that you could mess this one up, okay? So let's talk about that. If we start off with 5 plus 4, then we get 9, okay? And so 9 minus 6 makes 3, okay? I think of it as just putting money in your bank account. You put $5, then you put $4, and then you take 6 out. How many are you going to have? You're going to have $3 left in there. Okay, so again, just think of it as counting. That's really all that's happening here. And so this brings me to the bottom of the review, where we got some substitution and simplification steps. I'll do a couple of these problems and save a couple for you guys. So we'll start off with 23. So for 23, this is one of the main reasons why I tell you guys every time we're substituting, we want to put a blank parentheses. Okay, just put a blank parentheses. And then we go put the letters where they go. Okay, this says z squared. So the thing that goes in here should be z. And I see z is 3. So I'll put a 3 right there. Okay, it says that y is also equal to 3. So in y's place, I will put 3. And then now we think 3 squared is 3 times 3, and that's 9. And 9 minus 3 is 6. So this would be the way that we do this problem. All right. We don't have too many negatives to give you trouble, so the main thing here is for you guys to just understand to put the letters only for the letter that symbolizes it. So if we did 25, instead of writing j plus k, I'm going to write 3 plus, okay, well, what's k? Well, k is 5, so I'll write 3 plus 5 instead of j plus k, right? And then when I do minus j, I'm going to put minus, okay, and then j is equal to 3, so I write 3. Okay, again, we're doing this from left to right, so 3 plus 5 is 8, and then 8 minus 3 gives us 5. So do the same idea on these other problems. Maybe I'll do one more. All right, 26 would be a fine one to try right now. Okay, try 26 on your own and see if this makes sense to you. And then we'll go substitute these numbers in, right? So I was telling you guys, every time we substitute a number in, let's use parentheses. And if you really were to listen to me, that means that here, where I see x, I put a blank parentheses. Then I see a minus, and I put a parentheses. Then I see a z, so I put another parentheses. And then I see another z, so I put another parentheses. So like I said, every time that we see a letter, you turn it into a blank parentheses. And then we go put the number in there where it goes. Okay? So for x, I put 5. And then for z, I put 5. And then I put 5. Now right now, this might have you guys a little nervous, but it's not that bad. Okay, we write an equal sign. Of course, that 5, we're just going to copy. Okay, we can drop these parentheses without changing the meaning of everything. And now this minus sign we can copy. And now we got to figure out what goes inside of the big parentheses. So we'll copy the big ones. Okay. Inside of those parentheses, notice we got 5 in parentheses minus 5 in parentheses. So I want you guys to notice the difference, right? If I have 5 times 5 like this means 25, right? But if you see 5 minus 5 like this, that means 0. Okay? So that's what we see right here. This means 5 minus 5. So that's 0. So this just means 5 minus 0. Okay, and what is anything minus 0 is going to be whatever you started with, right? So 5 minus 0 is just 5. And that's how we would finish this one. Okay, so like I was saying, watch out for the parentheses. We'll be dealing with them for the rest of the year. But make sure that you understand they have a really specific meaning. And if you're feeling confused by parentheses, just ask me a question. And, the more specific, the better. So now we'll take a look at these simplification problems. All right, there's not that many, so I'll leave you guys a couple to do for homework too. Okay, so the problems say to simplify each expression. So now, this basically means that we need to understand the word simplify. Okay, so simplify is a way of taking something that's complicated and making it less complicated. Okay? If I had something, we'll make a new tab for now for the purposes of this little conversation. Okay? If I have x plus x plus x plus x, and then I have plus a plus a plus a. In this case, it's kind of organized still, right? So we can see it. In this case, I know that there's 4 x's, right? And I know here, I got 3 a's. So we could say that this is 4x plus 3a, right? So the idea is, if I had a lot more x's and a lot more a's, which one is easier to write? To just write 4x or to write all of these, right? And then what if it's 40x, right? This is much simpler to write than to write x plus x plus x plus x plus x plus x. You get the point. I'm not going to bother writing them all, okay? So this is why we have coefficients, and this is why we simplify things, because it would be too much to write in a lot of cases. So make sure we understand that. We're only going to be able to combine things with each other if they're the same kind of thing. So if I say 2x plus 3x, we can understand, well, 2x means x plus x. And 3x means x plus x, right? So how many x's do we have? We have 5 of them. Okay? But we can't get that confused with 2x plus 3y. Okay? This cannot be simplified anymore. Okay? This is already simplified as much as possible. Okay? So I'm just going to write cannot be simplified. So you guys get my point. Okay? We can only simplify these things if they are the same kind of variable, or if it's just constant numbers, right? If we just have a 2 and a 3 and a 5, just regular numbers, we can add those together. Okay, so let's go back and look at where we were. And we see in this problem, there are no other x's. So that means the 9x is already as simple as it can be. But now we have minus 2 and then plus 4. Okay, so negative 2 plus 4, well, where does that bring us to on the number line? What's negative 2 plus 4? Well, there's 0, there's negative 1, there's negative 2. Okay, if I take 4 steps, right, if I start at negative 2 and take 1, 2, 3, 4 steps, I end up at positive 2. Right, so that means that negative 2 plus 4 is plus 2. So notice the only thing that changed is this negative 2 plus 4 changed into 2. Okay, that's a little different than this problem over here. Okay, in this problem in 28, we have 2 different ends. So now we have to think about the way that this could look. All right, there's no other constant numbers. Okay, so we don't have any numbers, so we got to have an 8 right here. That cannot change. But what we have to understand is the meaning of this idea, this minus 4n. Well, minus 4n, this means minus n, minus n, minus n, minus n. 4 times, right? And then we have this extra n, minus n. Okay, so how many times do we subtract n? That's 5 times. So that's why we have minus 5n. Okay, so another way of thinking about it is there's like an invisible 1 in front of that. Okay, and then 4 plus 1 is 5. We just have to make sure that we keep it negative because we're adding 2 negatives. All right? So this problem would be completed there. Okay, again, only combine the coefficients if the variable has the same letter. Now on 29, we have n plus n. So we would call that 2n. And then again, because there's no other regular numbers, the 8 can't change and that has to stay the same. Okay, so I would leave number 30 as a homework problem for you. And then together we will do, let's do 32 and you guys can hopefully do 31 on your own, okay? So this is called the distributive property, okay? We might even have enough room for you guys to label it. Okay, the distributive property is pretty much one of the basic properties of counting, right? To make sure that we understand what counting is. So we'll talk about that for a little bit. The idea is that when I have a number that's outside of a parentheses and we have like something being added or subtracted inside that parentheses, so that means there's more than one number, more than one term in this expression, that means we have to do something special, okay? It means that I have to multiply this number times the first number. So we'll write that first. So negative 4 times negative 1, right? A negative times a negative makes a positive. So negative 4 times negative 1 makes positive 4. But now we also have to do the negative 4 times the second term, which is the negative 8x. So a negative times a negative makes a positive, okay? But 4 times 8 makes 32. And then the x is going to stay there. And so this is what we would get. Okay, so you try the same thing on this problem. Again, the distributive property tells us I have to multiply this 5 by both of these things. Okay, so 5 times v would give us 5v. Okay, what's the second term going to be? It's going to be a positive 5 times a negative 7. So a positive times a negative is a negative. Okay, and 5 times 7 is 35, so we have negative 35. Okay, so that leaves you guys with a little bit of homework, a couple examples, and I hope this was enough to make you guys feel like you had some support with this assignment. If you have any questions, bring them more. We can get extra practice for you. But again, this is just a quick little review for the Unit 0 test, which is on Friday. Good luck, everybody studying.